So hello everyone, let us continue our discussions on adjoint of a matrix. In the last class I have given the definition of adjoint of a matrix and I have explained how to find the adjoint of a matrix of order 2 as well as order 3, and apart from that I have given some properties of adjoint of a matrix. Okay, I have given only the properties but I have not explained any numericals related to those properties. So today I am going to discuss some numericals related to those properties of adjoint of a matrix. But before that, I will discuss some important theorems of adjoint of a matrix. Okay, some important theorems of adjoint of a matrix. ये एडजॉइंट ऑफ ए मैट्रिक्स जो है ये बहुत इंपॉर्टेंट है क्योंकि बाय यूजिंग द कॉन्सेप्ट ऑफ एडजॉइंट ऑफ ए मैट्रिक्स एंड बाय यूजिंग द कॉन्सेप्ट ऑफ सिंगुलर एंड नॉन सिंगुलर मैट्रिक्स वी कैन फाइंड द इनवर्स ऑफ एनी मैट्रिक्स. ओके, तो इनवर्स का एक मैट्रिक्स का इनवर्स फाइंड आउट करने के लिए सिंगुलर नॉन सिंगुलर का कॉन्सेप्ट जरूरत है एज वेल एज adjoint of a matrix. If you have the ideas about adjoint of a matrix and singular non-singular matrices, then you can easily find the inverse of any matrix. Okay, so some important theorems of adjoint of a matrix. The first one is, listen carefully, if A is any square matrix, if A is any square matrix of order n, then A into adjoint of A, this is the first theorem of adjoint of a matrix, A into adjoint of A, this is equal to adjoint of A into A, which is equal to determinant A into I, where I is the identity matrix of order n. Okay, the first theorem is, if A is any square matrix of order n, then A into adjoint of A, which is equal to adjoint of A into A, this is equal to determinant of A into In, where I is the identity matrix of order n. So this is the first theorem of adjoint of a matrix. The second theorem is, if A and B, capital letter A and B, we all know that matrix is always denoted by capital letters, whereas the elements are denoted by small letter, right? So if A and B are non-singular matrices of the same order. Now what is non-singular matrix? A square matrix capital letter A is said to be non-singular if determinant of A is not equal to 0. Yes or not? A square matrix capital letter A is said to be non-singular if determinant of A is not equal to 0. Whereas if determinant of A is equal to 0, then it is said to be a singular matrix. In the last class I have given the definitions and examples also, singular and non-singular matrix, right? So if A and B are non-singular matrices of the same order, then A into B and B into A are also non-singular matrices of the same order. ये पॉइंट याद रखना है. ओके, A into B as well as B into A are also non-singular matrices of the same order. If A and B are singular non-singular matrices, अगर A B दोनों ही non-singular होगा तो then their products are also non-singular matrices of the same order. Okay, next, the third point, the determinant of the product of matrices. Matrices means say A and B, capital letter A and B. The determinant of the product of matrices is equal to the product of their respective determinant. Once again I am repeating the third theorem. The determinant of the product of matrices. Matrices means more than one matrix are there. So let us consider there are two matrices, that is capital letter A and B. Okay, so the determinant of the product of the matrices is equal to the product of their respective determinant. That is, determinant of AB which is equal to determinant A into determinant B. Okay, determinant of AB is equal to determinant A into determinant B. This is the mathematical form of the third theorem. Okay, ये theorem और कल जो मैं एक प्रॉपर्टी दिया था एडजॉइंट ऑफ ए मैट्रिक्स का उसमें कंफ्यूजन मत रखना. उसमें क्या था? yesterday I have given this theorem, that is adjoint of AB if A and B are non-singular matrices. If capital letter A and B are non-singular matrices, then adjoint of A into B, which is equal to adjoint of B into adjoint of A. Yesterday I have given this theorem, that is theorem, that is properties of adjoint of a matrix. Okay, ये और इसमें confusion मत रखना. ये तो डायरेक्ट डिटर्मिनेंट का है और ये है एडजॉइंट का प्रॉपर्टी, राइट? द डिटर्मिनेंट ऑफ द प्रोडक्ट ऑफ मैट्रिसेस इज ऑलवेज इक्वल टू द प्रोडक्ट ऑफ देयर रेस्पेक्टिव डिटर्मिनेंट. दैट इज डिटर्मिनेंट ऑफ ए बी इज इक्वल टू डिटर्मिनेंट ए इनटू डिटर्मिनेंट बी, राइट? ओके, so these are the theorems related to adjoint of a matrix. Okay, now I'm going to discuss some numericals related to the properties of adjoint of a matrix. In the last class I have given the properties. Let us recall once those properties. The first property was if A and B are non-singular matrices, if A and B are non-singular matrices, then determinant of adjoint of A, this is equal to determinant A to the power n minus 1, where n is the order. If A and B are non-singular matrices of order n, of the same order n, then determinant of adjoint A is equal to determinant A to the power n minus 1. This one is one of the theorem. Next one is determinant of adjoint of A. This is equal to determinant A to the power n minus 1 whole square. Determinant of adjoint of A, this is equal to determinant A whole thing to the power n minus 1 whole square. Okay, ये भी एक theorem था. और एक अभी just now I have written one theorem, that is adjoint of A into B is equal to adjoint of B into adjoint of A. This is third property. And the fourth one was adjoint of A transpose. This is equal to adjoint A whole transpose. Adjoint of A transpose is equal to adjoint A whole transpose. And one more is there, that is adjoint of K into A. This is equal to adjoint of K into A. This is equal to K to the power n minus 1 into adjoint of A. Adjoint of K into A, this is equal to K to the power n minus 1 into adjoint of A, where K is a real number, where K belongs to R, that is a real number. So these are the properties I have given in the last class. Now I am going to discuss some numericals related to these properties. Okay, the first question is, if A is a matrix of order 3, if capital letter A is a matrix of order 3, which means A is a square matrix of order 3, and determinant of A is equal to 4, determinant of A is equal to 4, then find the value of determinant of adjoint A. Find the value of determinant of adjoint A. Solution number 1. Since here determinant of A is given, this is equal to 4. A is a matrix of order 3, which means n is equal to 3. Therefore, determinant of adjoint of A, this is equal to, we all know that determinant A to the power n minus 1, which means the value of determinant of A is 4. 4 to the power 3 minus 1, that means 16 is the answer. Okay, so वो property related questions आने से generally 1 mark का ही question आता है. So ये हो गया question number 1 का solution. Okay, determinant of adjoint of A is equal to determinant of A to the power n minus 1. Determinant A is given 4, n means the order, which is 3, so 4 to the power 3 minus 1, which is equal to 16. So this is the solution of the first question. Okay, now the second question is, if A and B are matrices of order 3 and determinant A equal to 5, determinant B equal to 3, find the value of determinant of 3AB. अच्छा, तो इसके लिए एक प्रॉपर्टी में पहले ही दे दिया था. If A is a square matrix of order n, if A is a matrix of order n, then determinant of KA, this is equal to K to the power n into determinant A. If A is a matrix of order n, then determinant of Ka, which is equal to K to the power n into determinant A. What is this K here? It is a scalar quantity. K is the scalar quantity. Now according to question, here A and B are the matrices of order 3, which means here n is equal to 3. Solution number 2, here n is equal to 3. Here n is equal to 3, determinant A is equal to 5, determinant B is equal to 3. तो फिर determinant of 3AB का वैल्यू क्या होगा? Determinant of 3AB, this is equal to 3 to the power n. What's the value of n here? N is 3. 3 to the power 3 into determinant of AB. And again we know that determinant of AB is equal to, here only it is written A, determinant of AB is equal to determinant A into determinant B. That means 27 into determinant A into determinant B. That is 27 into 5 into 3. If I calculate this one, we'll get, I think 405. So this is the solution of the second question. Okay, if A is a matrix of order 3 or of order n, suppose, then determinant of K into A, which is equal to K to the power n into determinant A, where K is a scalar quantity. So here the scalar quantity is 3. So determinant of 3AB, which is equal to 3 to the power n into determinant of AB. Here since n is 3, so that's why I have written here 3 to the power 3 into determinant AB. But determinant of AB is not given in the question. But we know one theorem, that is determinant of AB is equal to determinant A into determinant B. So we can write separately. Then after that put the values of determinant A and in determinant B. Okay. So this is the solution of the second question. Last one is, next question. If A is a square matrix of order 3 such that determinant of adjoint A is equal to 64. ये क्वेश्चन जो है, it is just the reverse of question number 1. देखो यहाँ पे क्वेश्चन नंबर 1 में डिटर्मिनेंट ऑफ एडजॉइंट ए का वैल्यू फाइंड आउट करना था, लेकिन यहाँ पे डिटर्मिनेंट ऑफ एडजॉइंट ए दिया गया है. यू हैव टू फाइंड ओनली डिटर्मिनेंट ए, बट इन दिस क्वेश्चन डिटर्मिनेंट ए इज गिवन. You have to find determinant of adjoint A. That is just a reverse question. Okay, 1 and 3, just a reverse question. So if A is a square matrix of order 3 such that determinant of adjoint of A is equal to, determinant of adjoint A is equal to 64, then find the value of determinant A. Okay, since we know that determinant of adjoint A is equal to determinant of A to the power n minus 1, so replace determinant of adjoint A by determinant A to the power n minus 1, which implies determinant A to the power n is given in the question. It is a square matrix of order 3, which means here n is equal to 3. So 3 minus 1, this is equal to 64. That is determinant of A square, this is equal to 8 square. 64 can be written as 8 square also. Therefore determinant of A, this is equal to plus minus of 8. Okay, so the value of determinant A is equal to plus minus of 8. So this is the solution of the third question. Number 3 and number 1, just reverse question only. Okay, so these are the numericals related to those properties of adjoint of a matrix, which I have discussed in the last class. And these are the theorems, some theorems related to adjoint of a matrix. Okay, so now I am going to discuss the next part, that is the inverse of a matrix. How to find the inverse by using the concept of this adjoint of a matrix. Okay, so now let's see the inverse of a matrix. After adjoint of a matrix, now I will discuss the inverse of a matrix. So how to find the inverse? How to find the inverse of a matrix? So पहले उसका meaning क्या है, definition क्या है, वो पहले मैं explain कर लेता हूँ. Along with that, some theorems are also there. So inverse of a matrix is what? Suppose there is a matrix A which is a non-zero square matrix of order n. A is a non-zero square matrix of order n. So then there exists another matrix B of the same order n such that AB equal to BA is equal to IN, where I is the identity matrix of order n. Once again I am repeating the definition. Listen carefully. Suppose A is a non-zero square matrix of order n, then there exists another matrix B of the same order n such that AB is equal to BA, which is equal to IN. Okay, such that AB is equal to BA is equal to IN. What is I? I is the identity matrix of order n. Then such matrix B is called the inverse of A. Okay, the matrix B is called the inverse of A, and it is denoted by A inverse, that is A to the power minus 1. Okay, it is denoted by A to the power minus 1, and the formula is to calculate the inverse of a matrix. The formula is A to the power minus 1, which means A inverse is equal to 1 by determinant of A into adjoint of A. Okay, तो एक मैट्रिक्स का इनवर्स फाइंड आउट करने के लिए क्या फॉर्मूला अप्लाई करना है? दिस वन, 1 by determinant of A into adjoint of A. देखो, if you know about adjoint of a matrix and singular non-singular matrices, then only we can find the inverse. इसीलिए पहले मैं singular non-singular और adjoint of a matrix discuss किया. If you don't have any idea about adjoint of a matrix, then how can we calculate the inverse? Because inverse calculate करने के लिए तो adjoint पहले पता होना चाहिए, right? Okay, so to calculate the inverse of any matrix, the formula is A to the power minus 1 is equal to, that is A inverse equal to, don't say A to the power minus 1, A inverse is equal to 1 by determinant of A into adjoint of A. But determinant of A must be not equal to 0. Why? If determinant of A will be 0, then A inverse does not exist, because 1 by 0 is undefined only, ना? तो ये बात हमेशा याद रखना है. तो मतलब एक मैट्रिक्स का जब इनवर्स फाइंड आउट करना है, द डिटर्मिनेंट मस्ट बी नॉट इक्वल टू 0. दैट मीन्स the matrix must be a non-singular matrix. In case of non-singular matrix, only inverse exists, whereas in case of singular matrix, inverse does not exist. ये बात हमेशा याद रखना है. Okay, once again I am repeating the definition. Suppose A is a square non-zero square matrix. Non-zero क्यों बोला गया है? क्योंकि डिटर्मिनेंट का वैल्यू 0 नहीं होना चाहिए. अगर डिटर्मिनेंट का वैल्यू 0 हो गया तो वो अनडिफाइंड हो जाएगा, which means inverse exist ही नहीं करेगा. Okay, so suppose A is a non-zero square matrix of order n, then there exists another matrix B of the same order such that AB equal to BA equal to IN. मतलब ये थ्योरम, ये भी जो थ्योरम है मैं अभी तो दिया था, theorems, some important theorems of adjoint of matrices, right? This is theorem number 2. AB is equal to BA. So AB is equal to BA, which is equal to IN, where I is the identity matrix of order n. Then the matrix B is called the inverse of A. Which matrix is called the inverse? The matrix B. The matrix B is called the inverse of A, and it is denoted by a to the power minus 1, that means a inverse. And for calculation purpose, you have to use this formula, that is a to the power minus 1, which means a inverse is equal to 1 by determinant of a into adjoint of a. By using this formula, we can calculate the inverse of a matrix, provided determinant of a is not equal to 0. If determinant of a is singular, if a is a singular matrix, then inverse does not exist. If a is non-singular, अगर not equal to 0 मिला determinant of a का value, then only inverse exists. ये बात याद रखना है. Okay? So this is the formula. Now, one of the important theorem. This theorem, a square matrix A is invertible. I have written here one word, invertible. Invertible is nothing but inverse. Invertible means inverse. Okay? If A is a square matrix A is invertible, that is inverse. If and only if, IFF means if and only if. If and only if A is non-singular matrix. ठीक है, अभी जो मैं ये फॉर्मूला में बताया था, इन्वर्टिबल कब होगा? इन्वर्टिबल मींस इनवर्स कब एग्जिस्ट करेगा? इफ द मैट्रिक्स इज नॉन सिंगुलर. वही थ्योरम है ये. ए स्क्वायर मैट्रिक्स कैपिटल लेटर ए इज इन्वर्टिबल मींस इनवर्स सेटिस्फाई करेगा और एग्जिस्ट करेगा इफ एंड ओनली इफ ए इज नॉन सिंगुलर मैट्रिक्स. अगर मैट्रिक्स नॉन सिंगुलर हुआ तो देन ओनली इनवर्स एग्जिस्ट, अदरवाइज नॉट. ओके, सो इसका प्रूफ इंपॉर्टेंट है ये थ्योरम. दिस इज इंपॉर्टेंट थ्योरम प्रूफ. सो एज पर द डेफिनेशन में यहाँ पे लिखा, बट डोंट राइट एज पर द डेफिनेशन, जस्ट यू हैव टू राइट दिस डेफिनेशन ओनली. ओके, सो जो डेफिनेशन यहाँ पे लिखा गया है, से A is a non-zero square matrix of order n, then there exists another matrix B of the same order such that AB is equal to BA is equal to IN. वही डेफिनेशन को यहाँ पे लिखना है, बट आई हैव रिटन हियर एज पर द डेफिनेशन. डोंट राइट एज पर द डेफिनेशन इन पेपर. ओके, सो अकॉर्डिंग टू द डेफिनेशन we have AB equal to BA equal to IN. Yes. Then take only one term. Since AB equal to BA equal to IN, so we can write AB equal to I also. Yes. Now take determinant on both sides. So determinant of AB, which is equal to determinant I. Determinant of AB is equal to determinant I. Now theorem number 3. Today only I have given the theorem of adjoint of a matrix. Determinant of AB is equal to what? Determinant A into determinant B or not? This is equal to, I have written here 1. Now, since I is the identity matrix, therefore, determinant of I, the value of determinant of I is always 1. Okay? Identity matrix को जब determinant form में लेके expand करना है by using cross multiplication type, then we get always 1. Okay? So that's why we can replace determinant of I by 1. So therefore determinant A into determinant B is equal to 1, which implies we can say that determinant of A is not equal to 0. Of course 0 तो नहीं होगा, because right hand side में तो 1 है, तो 0 कैसे होगा? So clearly we can say that determinant of A is not equal to 0. अभी क्वेश्चन तुम लोग पूछ सकते हो कि क्यों डिटर्मिनेंट ऑफ बी नॉट इक्वल टू 0 क्यों नहीं लिखा? क्योंकि थ्योरम में क्या दिया गया है? ए के बारे में दिया गया है, बी के बारे में कुछ नहीं दिया गया है. ए इज ए स्क्वायर मैट्रिक्स. स्क्वायर मैट्रिक्स ए इज इन्वर्टिबल इफ एंड ओनली इफ ए इज नॉन सिंगुलर. अगर ए नॉन सिंगुलर होगा तो देन ओनली इनवर्स एग्जिस्ट करेगा ना. यहाँ पे जो मैं बी ए इनवर्स लिखा, दिस इज नथिंग बट बी ओनली. ओके, दिस इज नथिंग बट बी, मतलब बी को ए इनवर्स से डिनोट किया गया है. सिंस वी आर यूजिंग द वर्ड इनवर्स ऑफ ए मैट्रिक्स, तो इसीलिए मैट्रिक्स बी को ए इनवर्स से डिनोट किया गया है. लेकिन मेन काम है सिर्फ ए का, इसीलिए तो यहाँ पे लिखा ए इज नॉन सिंगुलर मैट्रिक्स. तो हो गया ना डिटर्मिनेंट ऑफ ए नॉट इक्वल टू 0, विच मीन्स ए इज नॉन सिंगुलर. ठीक है, इसका कन्वर्सली भी प्रूफ करना है. यहां तक अगर प्रूफ करोगे तो फुल मार्क्स नहीं मिलेगा. Hence A is a non-singular matrix. यहाँ तक लिखने से full marks नहीं मिलेगा. Okay. If after that you have to prove the conversely part also. Now conversely, let A is a non-singular matrix. That is determinant of A is not equal to 0. Conversely का मतलब है कि हम लोग खुद assume करेंगे कि A एक non-singular matrix है. We have to assume that A is a non-singular matrix. That is the determinant of A is not equal to 0. Now, by theorem 1, I have written here by theorem 1. So, which one is the first theorem? Today only I have given the first theorem. By theorem 1, we have this one. A into adjoint of A, which is equal to adjoint of A into A. This is equal to determinant of A into In. Today only I have given this theorem, the first theorem, theorem of adjoint of a matrix. So by theorem 1, we can write A into adjoint A, which is equal to adjoint of A into A. This is equal to determinant of A into In or not? Yes, this is the first theorem. After that, I see the next step. This is important step. See the next step. What I have written here? A into, ये एडजॉइंट ऑफ ए के जगह में 1 बाई डिटर्मिनेंट ऑफ ए इंटू एडजॉइंट ए कहां से आ गया? एडजॉइंट ए तो ठीक है, एडजॉइंट ए यहां पे भी है, मैं यहां पे भी लिखा, लेकिन ये जो 1 बाई डिटर्मिनेंट ए है वो कहां से मिला? सी द राइट हैंड साइड, डिटर्मिनेंट ऑफ ए इंटू आई एन इज देयर ना, ये डिटर्मिनेंट ए को मैं क्रॉस मल्टीप्लाई करके नीचे लेके आया. ओके, ए दिस वन ओनली. Instead of adjoint of A, I have written here 1 by determinant of A into adjoint A. This 1 by determinant of A is nothing but this one only, this determinant A. Just cross multiplication किया यहाँ पे. In the same way, you have to cross multiply this one also. With ये term के साथ भी cross multiply किया, which means 1 by determinant A into adjoint A whole into A. This is equal to I. बिकॉज यहाँ पे डिटर्मिनेंट ऑफ ए इंटू आई है, लेकिन यहाँ पे मैं आई क्यों लिखा? क्योंकि ये डिटर्मिनेंट ऑफ ए को तो मैं क्रॉस मल्टीप्लाई कर दिया यहाँ पे, इसीलिए तो यहाँ पे सिर्फ आई लिखना पड़ा, डिटर्मिनेंट ऑफ ए नहीं लिखा मैं. नाउ द क्वेश्चन इज व्हाई वी नीड टू राइट दिस डिटर्मिनेंट ऑफ ए लाइक दिस, 1 बाय डिटर्मिनेंट ऑफ ए, 1 बाय डिटर्मिनेंट ऑफ ए. व्हाट इज द फॉर्मूला टू कैलकुलेट द इनवर्स ऑफ ए मैट्रिक्स? ए इनवर्स इज इक्वल टू 1 बाय डिटर्मिनेंट ऑफ ए इंटू एडजॉइंट ए ना. मुझे तो वो फॉर्म लाना पड़ेगा, 1 बाय डिटर्मिनेंट ऑफ ए इंटू एडजॉइंट ऑफ ए. सो दैट्स व्हाई वी नीड टू cross multiply this determinant of A with these two terms, okay, which implies A into this one only, A into 1 by determinant of A into adjoint A. I have written here B, so A into B, which is equal to B into A. This is equal to I. यही तो definition था inverse of a matrix का. ये conversely part proof कर रहा हो. एक्चुअली थ्योरम में प्रूफ करने के लिए क्या बोला? ए स्क्वायर मैट्रिक्स ए इज इन्वर्टिबल. इन्वर्टिबल मींस इनवर्स इफ एंड ओनली इफ ए इज नॉन सिंगुलर. तो ए नॉन सिंगुलर है, ये प्रूफ कर लिया, लेकिन कन्वर्सली पार्ट क्या प्रूफ करना है? कन्वर्सली पार्ट का मतलब है कि वी हैव टू एज्यूम दैट द मैट्रिक्स इज नॉन सिंगुलर. विथ द हेल्प ऑफ दैट कंडीशन यू हैव टू प्रूव द डेफिनेशन ऑफ इनवर्स ऑफ ए मैट्रिक्स. दैट इज कॉल्ड कन्वर्सली पार्ट. तो मैं इसलिए कन्वर्सली में एज्यूम कर लिया कि लेट ए इज ए नॉन सिंगुलर मैट्रिक्स ऑफ नॉन सिंगुलर मैट्रिक्स, दैट्स व्हाई डिटर्मिनेंट ऑफ ए इज नॉट इक्वल टू 0. देन बाय यूजिंग थ्योरम नंबर 1 वी कैन राइट दिस वन. आफ्टर दैट आई हैव रिटन ए बी इक्वल टू बी ए इक्वल टू आई, जो डेफिनेशन है इनवर्स ऑफ ए मैट्रिक्स का. व्हाट इज बी? वेयर बी इज इक्वल टू, बी इज नथिंग बट दिस पार्ट ओनली, वेयर बी इज इक्वल टू 1 बाय डिटर्मिनेंट ऑफ ए इंटू एडजॉइंट ऑफ ए. जस्ट मैं इसको रिप्लेस किया बी से. यस, क्यों रिप्लेस किया? क्योंकि डेफिनेशन में ही तो है, मैं बोला था ना, ए इनवर्स इज नथिंग बट बी ओनली. ए इनवर्स इज नथिंग बट बी ओनली. ओके, सो यहाँ पे बी के जगह में ए इनवर्स लिखा गया है, विच इज इक्वल टू 1 बाय डिटर्मिनेंट ऑफ ए इंटू एडजॉइंट ऑफ ए. इंस्टेड ऑफ ए इनवर्स इफ यू विल राइट बी, देन ऑल्सो देयर इज नो प्रॉब्लम. सो बी इक्वल टू ए इनवर्स इक्वल टू 1 बाय डिटर्मिनेंट ऑफ ए इंटू एडजॉइंट ऑफ ए. ओके, so thus A is invertible. Thus A is invertible. Invertible means inverse will exist, and A inverse equal to 1 by determinant of A into adjoint A. So this is one important theorem with proof. ये proof भी चाहिए, exam के लिए important है. Okay, so this is all about the inverse of a matrix, the definition and the theorem. Some properties are also there. Now I will give those properties of inverse of a matrix. So after the definition of inverse of a matrix and the theorem, now I will discuss some properties of inverse of a matrix. So properties of inverse of a matrix. If A and B, if capital letter A and B are two square invertible matrices, invertible means inverse only. If A and B are two square invertible matrices of the same order, if A and B are two square invertible matrices of the same order, then the first theorem, a to the power minus 1, whole thing to the power minus 1 is equal to a. That means a inverse whole inverse is equal to a. The second theorem is ab whole inverse is equal to b inverse into a inverse, not a inverse into b inverse. It is just like transpose. कॉन्सेप्ट ट्रांसपोज का नहीं है, लेकिन प्रॉपर्टी थ्योरम जस्ट ट्रांसपोज के जैसा ही है. ए बी होल ट्रांसपोज इक्वल टू बी ट्रांसपोज इनटू ए ट्रांसपोज. सो हियर आल्सो इन केस ऑफ इनवर्स आल्सो सेम ओनली. ए बी होल इनवर्स इक्वल टू बी इनवर्स इनटू ए इनवर्स. ट्रांसपोज और इनवर्स का कॉन्सेप्ट सेम नहीं है. मैं वो बोल रहा हूं कि थ्योरम वैसा ही है. टू दी पावर माइनस 1 के जगह में मैं वहां पे ट्रांसपोज यूज किया था. सो ए बी होल ट्रांसपोज इक्वल टू बी ऑल नो बी ट्रांसपोज ए ट्रांसपोज. इन द सेम वे इन केस ऑफ इनवर्स ऑल्सो वी कैन राइट ए बी होल इनवर्स इज इक्वल टू बी इनवर्स इंटू ए इनवर्स. नंबर 3, ए ट्रांसपोज होल इनवर्स विच इज इक्वल टू ए इनवर्स होल ट्रांसपोज. ओके, ए ट्रांसपोज होल इनवर्स इज इक्वल टू ए इनवर्स होल ट्रांसपोज. नंबर 4, determinant of A inverse is equal to determinant A to the power minus 1 whole inverse. Okay. Number 5, A into A inverse which is equal to A inverse into A. This is equal to I. A into A inverse. This is equal to A inverse into A. This is equal to I. ये जो है inverse का ही तो definition है. If I replace this A inverse by B, it can be written as AB is equal to BA. This is equal to I, where B is nothing but A inverse only. Inverse का जो definition है वही use किया है यहाँ पे. Okay, this is property number 5. Now the property number 6, that is the last property of inverse of a matrix. K into A whole inverse is equal to K into A inverse. K is a scalar quantity. Okay, K is not a matrix, it is a scalar quantity. So K into A whole inverse is equal to K into A inverse. So these are the 6 properties of inverse of a matrix. And one thing you have to remember, only square matrix have adjoint and inverse. That means in case of square matrix, if the given matrix is a square matrix, then only we can determine adjoint of that matrix as well as we can find the inverse of that matrix. Okay, अगर वो matrix in square matrix नहीं होगा तो we cannot determine adjoint or inverse of a matrix. Okay, so these are the properties. तो एक मैट्रिक्स से इनवर्स फाइंड आउट करने के लिए उसका रिक्वायरमेंट क्या क्या है? व्हाट इज द फॉर्मूला टू कैलकुलेट द इनवर्स? ए इनवर्स इज इक्वल टू 1 by determinant of A into adjoint of A, right? Where determinant of A must be not equal to 0, means you have to check whether A is a singular or non-singular matrix. If A is a singular, then A inverse does not exist. If A is non-singular, then only we can find the value of A inverse, right? So what are the requirements to calculate A inverse? First of all, you have to find determinant of A. Don't find first adjoint of A. क्योंकि अगर determinant of A का वैल्यू 0 हो गया तो इनवर्स ही तो एग्जिस्ट नहीं करेगा. तो इनवर्स एग्जिस्ट नहीं करेगा तो adjoint A निकाल के क्या फायदा? That's why whenever you are asked to find the inverse of any matrix, first check whether it is singular or non-singular, whether the matrix is singular or non-singular. If it is non-singular, then only we can proceed. If it is singular, then stop here because inverse does not exist. Let us take one example. Find the inverse of the matrix. Find the inverse of the matrix 2, 3, minus 1, 4. Find the inverse of the matrix, say A is equal to 2, 3, minus 1, 4. Okay, so in order to find the inverse, first of all you have to check whether the matrix is a square matrix or not. Yes, it is a square matrix. So since it is a square matrix, that means we can find inverse. लेकिन इनवर्स फाइंड आउट करने के लिए पहले ये स्क्वायर मैट्रिक्स से क्या चेक करना पड़ेगा? whether the given matrix is singular or non-singular. So let us find first determinant of A. So determinant of A, this is equal to determinant 2, 3, minus 1, 4. Expand it and check whether it is singular or non-singular or not. That is 8 plus 3, which is equal to 11. Yes, 11. So determinant of A is not equal to 0. Now since the determinant of A is not equal to 0, which means we can say A inverse exists. You have to write in this way, okay? A inverse exist करेगा, okay? लेकिन A inverse exist करेगा, इसके लिए formula क्या है? Now we know A inverse is equal to, the formula is 1 by determinant of A into adjoint of A, right? Okay, so determinant of A का value तो already निकल गया, that is 11. Now you have to find adjoint of A. In the last class I have discussed about how to find the adjoint of matrix of order 2. Shortcut method जो है वो apply कर सकते हैं यहाँ पे. So since here A equal to 2, 3, minus 1, 4, how to find the adjoint? Adjoint of A is equal to, what is the shortcut method? Interchange the values, interchange the position of A11 and A22. That means interchange the diagonal elements. Interchange the diagonal elements. So that means यहाँ पे आ जाएगा 4 और ये हो जाएगा 2. And change the signs of non-diagonal elements. No need to change the position of non-diagonal elements. Just you have to change the signs of non-diagonal. So यहाँ पे +3 है तो this will be now -3. यहाँ पे -1 है तो ये हो जाएगा +1. This is adjoint of A, shortcut method. If you want to use that long method by finding the cofactors, you can apply. But if it is a short question like 2-3 marks, then no need to apply. Directly you can find. If it is 2 marks question, then whether it is 2 mark or 3 mark is that it doesn't matter. Okay, अगर order 2 है तो generally इतना ज़्यादा marks नहीं आएगा, तो इसीलिए बेहतर होगा कि ये shortcut method use करना, ठीक है? In case of order 2, just you interchange the diagonal elements and change the signs of non-diagonal to find the adjoint of any matrix. So this is all about adjoint. Okay, now put all the values here. There is 1 by 11. 1 by 11 into adjoint is also a matrix only. So matrix 4 minus 3 1 2. Now multiply this one. Multiply this this part because it is a scalar multiplication. 4 by 11 minus 3 by 11, 1 by 11, 2 by 11. So this is all about the inverse of this matrix X. Okay, so this is the solution of this question. First of all, you have to check, once again I am repeating, first of all you have to check the value of determinant of A in order to find the inverse of any matrix. Because if determinant of A is equal to 0, then inverse does not exist, then no need to proceed. So that's why always you have to check first determinant of A and then only find out adjoint of A. If inverse exists, then only you have to find adjoint of A. Okay, so this is the solution of this example. So in the next class I will give some more examples and I will discuss some more topics also. Okay, so thank you for today.